Hello, dosto. Welcome to NCRT Reader channel. So this question is about two identical tennis balls, each having mass m, and the charge q are suspended from a fixed point by a thread of length L. What is the equilibrium separation when each thread makes an angle theta with the vertical? So equilibrium separation means what it is, that at that instant the ball will not have any kind of resultant force over there. That means it will be in equilibrium. So if I'll talk about this single, this one ball is having charge q, another ball is also having charge q, and that separation between the ball, it is given to you d, and this is the reference line, or you can say the line joining midpoint line. It is making some angle, a small displacement angular, it is theta. By that instant, this thread will having some tension over there on this charge, that T is the tension. One force mg will be there due to the this force of gravity there it will be, and there will be a repulsive force on this charge, it will be, that is called electrostatic repulsion. So here I have just diagram it already. So you can see this angle will be theta only, and this is the tension by the thread it is. So if you balance the force over there, so we'll be having two component of this tension. One is along the vertical direction, that will be t sine t cos theta, and the another will be opposite to the electrostatic force. Here it is, that is t sine theta. Now you can see here that if this charged particle is in equilibrium, then we can say that this force T sine theta will balance this k q square by d square, and this T cos theta will get balanced by the mg only. So once we balance the forces over there along the horizontal direction and vertical direction, so for equilibrium of q charge over there, if it is in equilibrium position, in that situation, that t sine theta will be balanced by electrostatic force over there. So it is kq square by d square. This is the equation 1 I am assuming here. And then if you balance the vertical force over here, so it will be t cos theta, and that will be balanced by mg. So it is t cos theta that is getting balanced by mg. Mg is the force by the earth it is. So we can see here, if you divide equation 1 by the equation 2, what we'll be getting here is t sine theta, t get cancel out, so it will be tan theta, and here tan theta will be, it is k q square by d square, and then it is divided by mg. So this is the value of tan theta we are getting, and you know that here theta is very small. So in two identical in question, it is, we need to understand that theta is smaller, suspended from the fixed point by thread, and what is the equilibrium separation for a small angle theta. So it is mentioned in the question that this is very important to understand here. So a small angle theta, once it is a small angle theta, we can write this sine, this tan theta will be, equal to, it will be equivalent to sine theta. And then we can write the sine theta value in the approx, whatever the above diagram we have. If you write the sine theta value here, so sine theta will be, it will be perpendicular will be d by 2 here, and then it is hypotenuse, so d by 2 divided by L. So it is d by 2 divided by L. So simply I can write here d by 2 L. So this is the value of sine theta here. So I can replace this equation. If I assume here it is 3. So from 3 I can write, here it is d by 2L. This will be equal to k q square by d square, then it is mg. Actually we are looking for finding the value of d, here. So that d value for that charge will be in equilibrium position. So d square will come left hand side, so it will be dq, and the remaining term will be kq square, then it is twice of L divided by mg. In the next step, you can write over here, it is d. We are looking to find the d only. So in next step, you can write here, it is 2k q square L divided by mg to the whole power, it will be 1 by 3. So this is the, I think, answer. It should be the answer. And we can check that answer, which option we are having. This D option, D is coming like that. So it is in numerator, you can see what is the numerator. We are having 2kq square L divided by mg it is. So in which option we are having? It is in which option we are having any? It is d by. So 2. Okay. So in K, we haven't replaced this K value here. K is not given in the option. It is written in terms of pi and epsilon naught. So we have to change that K value here. But we know that in SI unit, what is the value of K? K is 1 by 4 pi epsilon naught. So once we replace this K value here, it will be, this D will be, here it is 2. And then K is 1 by 4 pi epsilon naught. So it will be 1 by 4 pi epsilon naught term, it will be in denominator mg. Then we have q square, then we have L, and to the power of 1 by 3. So once you see here, this 2 get cancelled out here, 2 pi, and the q square by L. So this will be the final result, I hope so, because we haven't changed the K value it is. So finally, D we are getting here, it will be q square times L divided by 2 pi epsilon naught mg to the power, it will be 1 by 3. So this will be the final result. And this is in which option you can see here, q square L and divided by 2 pi epsilon naught mg. So this is in option 1, but here it is 1 by 2. So this is not the correct one. So here the second option, you can see B option is correct. In B, it is q square L by 2 pi epsilon naught mg to the power. So this will be the result, final result. So this question is mainly based on equilibrium of the two charges. This kind of question you must have done in pith ball when it is charges. So electrostatic force will be there, 1 mg will be there, and there will be some thread tension will be there, and then balance horizontal and vertical forces will be getting the tan theta value, and on the basis of that we have the relation of D. I hope it is clear. Thank you.